The concept of fixed length subnet masking can only take you so far. What do I mean by that? Well, it's not an efficient method of subnetting, but it's a good starting point to subnetting. So here is what I mean by fixed length subnet masking. We are taking a class A, B, or C network. In this case, in our example, we have a class B network with its default subnet mask, and then we subnet it once. So in this particular example, what have we done? We've subnetted it down to a /24. And you'll notice that we have /24s deployed absolutely everywhere within the organization. Now, this may or may not be efficient. And the reason why it may or may not be efficient is because of the number of addresses we truly need in those networks. So, for example, over here off of router A, we only need 9 hosts. Well, a /24 gives us 254 hosts within a network. So what do we do with the rest of those IP addresses? Well, we just put them aside and hope we need them at some point in time. So this branch office, let's say, never has any more than 30 users in it, ever. Well, then that means all the rest of those addresses are wasted. Likewise, down here off of router B, we only need 28 hosts. But let's say the max we ever get is 128. Well, then we still have wasted almost half of those addresses. And in class C, again, a 28, or class C, router C with 28 hosts right now, but maybe in a couple of years from now, we end up with 75 hosts in that branch office. Again, a lot of wasted addressing here, addresses we are not using. But the biggest waste here is across these WAN links. These WAN links are point-to-point links, meaning we only need 2 addresses. That's it. One address for router A, one address for headquarters, one address for router B, one address for headquarters, one address for router C, one address for headquarters. So a /24 gives me 254 usable addresses, but I only need 2. That means we're wasting 252 addresses each and every single time. So 252 addresses wasted for that link between A and headquarters, 252 addresses wasted between B and headquarters, 252 addresses wasted between C and headquarters. Yeah, a lot of wasted addresses. So instead, what we are going to utilize in the real world to make sure we are more efficient with our addressing is variable length subnet masking. So what is variable length subnet masking? Well, it's subnetting a subnet. Subnetting a subnet. So let's back up here. We had our /16 and we turned it into a bunch of 24s. We subnetted our class full address. Our class B /16 network, we subnetted it into a whole bunch of classless /24s. Now we're going to take one of these /24s or 2 of them or 3 of them or whatever we need, and we're going to subnet them again. So we are subnetting a subnet. So why might we want to do that? Well, look at this /16 we have here. 172.16.00/16. That was our primary major classful network. One network, 65,534 devices capable of being housed within that one network. Not practical. So what do? We subnet it into a whole bunch of /24s. So we borrow 8 bits from that /16 going down to a /24. And by borrowing those 8 bits, we created 256 /24s. All right. So in headquarters, I used a couple of those /24s. We might use more. But the idea behind this now is let's take one of those, just one of those /24s, and subnet it again. So instead of having a whole bunch of /24s throughout our network, why not use the /24s where we need them and create smaller networks from the /24s and deploy those elsewhere? So we're going to focus on the 172.16.14.0/24 network. 172.16.14.0/24 network. So just one of the /24s that were created out of the 256. And what we're going to do is we're going to subnet it again. So subnet a subnet. And what we're going to do in this case is we're going to make sure that we come up with a subnet mask that will support the maximum number of hosts that we need over here in the branch offices, which is 28. So how many host bits do I need left over to make sure we get 28 hosts? Well, 2 to the power of 5 is 32. So I need 5 host bits left over at a minimum to hit my 28 host mark. So 5 host bits left over. So that means /27 means I borrow 3 bits with 5 host bits left over. So that's what we're going to go with, a /27. So watch what happens here. We have a /27 that was created from the /24. That means we borrowed 3 bits. So let's figure out how many subnets we created now. We created 8 subnets in total. 8 subnets that can each support 32 minus 2 hosts. 32 minus 2 hosts. So 30 hosts. So 8 subnets, each supporting 30 hosts. That will take care of our 3 branch offices we have here. So the /27 subnet mask is 255, 255, 255, 224. And then we have our block size. So what are we counting by in the 4th octet here? I know it's the 4th octet because that is where we're going to find the very last one in binary. That's where /27 ends, in the 4th octet. So let's start counting by 32 in the 4th octet. So the first subnet's 172.16.14.0/27. Add 32 to that, you get 172.16.14.32/27. Then you get 172.16.14.64/27, 96/27, 128/27, 160/27, 192/27, and last but not least, 224/27, and that's our 8 subnets that we created.